semiconductor devices. So it is one of the important parameters in the material devices. So mainly we have the semiconductor devices, we have the Zener Diode. We have the diode is a two-terminal of electronic component that conducts the primarily is one direction. So it's mainly we have anode and the cathodes. Mainly anode is a positive point and cathode has a negative point, negative terminals. So it blocks the current to opposite direction. It's a unidirectional behavior. It is called as a rectification. Mainly it's a unidirectional one. So its behavior is called as a rectification purpose we can use it. The Zener diode is particularly it's a Zener diode is particularly for the diode that allows the current flow not only the one form, it's another. It's called as a cathode. It's anode to cathode, but it is also reverse direction when it is called as it's a Zener voltage. So it's to reach. And also the Clarence Melvin is a Zener is American physicist. It inverse the Zener diodes. So this is the main advantage of the Zener diodes. Having the anode and the cathode potential is available. So, the Zener diode, it's the anode and we have the positive terminal and the cathode is a negative terminal. So they start to conduct one negative to another things. So it's a physical symbol of this anode and the cathode. We have the Zener diode symbol. In this we have the Zener diode packaging. So in that we have semiconductor materials we have used. We have the two terminal devices. So here it is anode and the cathode is there. So this terminal is called as anode terminal. This is a cathode terminal because it's only the negative terminal, negative potential is implemented here. So this is the semiconductor devices of the Zener diode we use it. So here it's having the energy band gap is there. So we are using anode and the cathode. We already discussed. We have two terminals of devices. It's a current flow. It's a conventional current flow is there. So we have p-type material and n-type material. We have bonded here. So anode and the cathode is there. So automatically we start flow. That is called as a conventional current flow is there. Both we start to conduct from anode to cathode terminal. How they start to conducting material is p-type and n-type materials to start conducting the devices. So we have the anode and the cathode. This is a positive negative terminal. So like a symbol. So this is a structure of semiconductor Zener diode. So it's a semiconductor generator. We have anode and the cathode terminal. So it's a blockly we could connect. So it's a negative terminal. So anode is a positive terminal. So it's a conventional current flow from anode to cathode mainly. Here it is the graphical representation and the characteristics of Zener diode. We have the characteristics. We have voltage and the current. In between that, we have followed the 0.3 is a germanium and 0.7 is a silicon of cutting voltage of conducting places. So it's having the forward operating region. So we have the voltage drop of these two terminals. It's called as a 0.3 and 0.2. In case of germanium metal in the sense 0.3. In case of silicon metal in the sense 0.7 voltage to unity breakdown to start to conduct. So this is a forward bias we have. In case of the reverse bias or reverse breakdown voltage we have the leakage current is also possible. So mainly this is a reverse operating region. So leaking current is also possible. It's not able to. It's a very nearest. It's a 0.3. But in case of reverse breakdown, it will take high voltage range and to start to conduct the reverse bias. So it will take a more voltage to start conducting. This is the main characteristics of the Zener diode. So mainly we focused the current and the voltage. In between that the current and voltage characteristics we have 0.3 and 0.7 for each and the germanium and the silicon respectively. So we will start in anode to cathode conduction. Maybe in forward bias we will start to conduct 0.3 to 0.7 voltage. It's very minimum. But in case of reverse breakdown, we need more leakage current to start to conduct in reverse bias or reverse mannerism. And also the semiconductor Zener diode have the symbol that the cathode and anode we have two types of symbols we have. This is called as we already seen what we see we have forward bias that's the plus voltage forward and the plus current of forward bias. So it's a forward bias region to start conducting the 0.7 voltage level cutting volt. But in case of reverse, it's a Zener breakdown region. So it has the reverse of both the reverse current and the reverse voltage. That's IVR, that's a VR, that's a negative VR of and negative current, or so it's a reverse current that the reverse bias start to conduct this constant Zener voltage level is available here. Both things will be possible. But the Zener diode is voltage reference. We have the reference V in and V out. We have that reference values, the resistance of R1 and the diode's value. That's fine. High voltage we can use to Zener diode. In power supplies, the many of the circuits in the Zener diodes find applications such as a constant voltage that provide the voltage references. So only the conduction that input and voltage to greater than the Zener voltage, the resistor should have the minimized value such as a maximum current flow through the device. This is the main thing of the Zener diode. Thank you.